Today we started a new chapter. We started our chapter on systems of linear equations, and today we focused on what a system is and what a solution of a system is, and then how to solve it by graphing. So a system of linear equations is formed by two or more linear equations. So we've been working with linear equations now for somewhere between about 9 to 12 weeks, and we're just kind of taking that and adding a little bit to it. So now we're going to be working with two or more linear equations on every problem that we attack. So the solution to a system is the ordered pair at which the two lines intersect. This is the point at which the two equations are equal to one another. So starting out today, we worked on a warm-up where we graphed two lines on the same coordinate plane, and then we looked for where they crossed, and we wrote that ordered pair. Then we did a little bit more with it from there, but it was just to review graphing. So this video today, I am going to talk a little bit about systems, but I'm really going to focus on reviewing you guys over slope-intercept form, okay? So what I did here, and we reviewed this in class with our notes, is there's actually three different types of systems that you might see when you're solving systems. So the first one is called an inconsistent system, and that's when you graph the two lines and you realize that they're parallel. So remember, you actually don't have to graph in order to see if something's parallel. Remember that parallel lines are going to have the same slope but different y-intercepts. So whether you notice it with the equations or you actually graph, if you see two parallel lines in a system, you know that there's going to be no solution. Because remember, the solution is the ordered pair where the lines cross. So these lines would never cross, therefore there is no solution to this system. Then there are two types of consistent systems. There's consistent independent, and that's the type that we looked at mostly today, and that's where when we graphed our two lines, we noticed that there was one point of intersection, and we wrote that point of intersection as an ordered pair. So don't forget, whenever you're writing your solutions, you want to write them as x, comma, y, because that ordered pair is the actual solution. So consistent independent systems are going to have one solution, and that's going to be that ordered pair where they cross. Then we have consistent dependent systems. That's when you take and you graph one line, and then you realize that the other line has the same equation. So it's actually two lines graphed on top of one another. It winds up looking like one line on your graph, and that's going to have an infinite number of solutions. Because if it's two lines graphed on top of one another, they are touching everywhere. Okay, so from that point, the next thing that we did was we just kind of looked at some equations and we worked on graphing them and looking for the solution to a system. So what I've done here is I've actually already graphed this system, so let me rewrite it for you. The original system was y equals negative 2x plus 1 and y equals x minus 8. So this is my actual system that I'm working with. So the first thing that I did for this top line right here is I graphed. So looking right here, I noticed that my y-intercept, that's the number that's being added or subtracted when it's in slope-intercept form, that's b, is positive 1. So you would go to the graph and put a point on positive 1. So I'm going to do that. I put a point on positive 1 right here, and then I go back and look at my slope. Now my slope here I see is the number in front of x. It happens to be negative 2. So what that means is I need to go down 2 and over 1 and put another point. So I have a point on my graph right there. I'm going to continue that process until I get this line that I've created right here on my graph. Then I'm going to do the same thing with the second line. I notice that my y-intercept is negative 8, so I'm going to put a point on negative 8. And then my slope is 1. So I rise 1, run 1, put another point, and that's going to give me this line. Now remember, the solution to a system is where the two lines intersect. So I see that right here they intersect. So the ordered pair for that point of intersection is 3, negative 5. So that's the actual solution to my system that I was looking for. That's the point where the two lines intersect, and that's going to be where these equations are equal. So today in class we did several examples that look like this, and we will finish up working on what happens when the equations are not in slope-intercept form tomorrow. If you have any questions, please come in for tutoring, and I will see you tomorrow.